At this point, you've worked a couple problems using the quadratic formula. And if you've been noticing in the sample problems, the directions have been kind of showing you what type of solutions we have and how many solutions that they're going to be. Well, we have a shorter way of figuring this out as opposed to solving the whole thing. The expression b squared minus 4ac, which sits under the radical portion of the quadratic formula, is called the discriminant. Now you got to understand, we're only taking the part underneath the radical. The radical is not involved with the discriminant. So if we take the b squared minus 4ac and we just calculate that singular part, it's going to give us one of three possibilities. And if you look at this little chart here, we can see that that value could be a positive number, could be bigger than 0. It could actually equal to 0, or it could be less than 0. And so that's going to tell us specifically what types of solutions that we're going to be dealing with. And you can see if it's greater than 0, if it's a positive number, we're dealing with real solutions, and we have two of them. If it's less than 0, or it's negative, then we're going to have the radical of a negative, which is an imaginary solution. Now the 0, if it's 0, that brings in a special case where we only have one real solution. And this is when we're dealing with a perfect square trinomial. So if we go and look at an example, we've given you a nice example here in example 2. You can see we have three different problems. And all we've basically done in these three problems is change the c value. Now, if you look here, you can see if we take the discriminant of each of them, by changing that c value, that changes what the potential discriminant is equal to and then what the potential solutions are equal to. And you can see the difference there. Now, something that we've talked about in class before is the fact that the zeros represent the roots or the types of solutions that we have. And then again, here we can see that if we, in this green equation for x squared minus 6x plus 8, it crosses the x-axis twice, so it has two intercepts or two real solutions. X squared plus minus 6x plus 9 is a perfect square trinomial, so it only has one solution. And you can see x squared minus 6x plus 10 has no zeros, so this would imply that it has two imaginary solutions. So you can get a visual sense of what the discriminant is telling you as well. So let's take a look at sample problem 4. Here we have three problems for you to work. All we want you to do is to find the discriminant of the quadratic and give the number and types of solutions that are involved. Alright, so let's take a look at this. So if we remember, the discriminant is b squared minus 4ac. It does not involve the radical, so keep that in mind. So in this first one, that's going to be 6 squared minus 4 times a times c. If you work that out, you end up getting 0, which tells us that this must be a perfect square trinomial, and it could be factored. So that would be one real number solution. Okay, and so that's basically what the discriminant tells us. The other nice thing about the discriminant, if I wanted to solve this and I noticed that the discriminant equals to 0, then it would probably be a pretty good idea for me to factor it because it's a perfect square trinomial instead of going through the entire quadratic equation. Let's take a look at the next one. We have 6 squared minus 4 times a times c. This is going to give us 36 plus 144, which is 180. Notice, it does not matter what the value is, long as it's a positive value, long as it's greater than 0, then we can say that this is two real solutions. And then lastly, we have 6 squared minus 4 times a times c. We have 36 minus 180, which leaves us negative 144. Again, doesn't matter the actual value, just that it's less than 0. And this is going to tell us that we have two imaginary solutions. Alright, and that's the final video on quadratic formula, using the discriminant to tell the number and type of solutions.